Okay, so we're trying to do number 21 in 8.3. And so I have this kind of, sort of difficulty ramping. So first things first, I have to Laplace transform my y double prime plus y on the left-hand side. And so I have Laplace transform of y double prime plus Laplace transform of y. And that's going to equal... okay, so now I get to look stuff up in the table. So I need the Laplace transform of t. So I'm thinking that looks like a t to the first power, which in the sheet goes to 1 factorial over s to the 1 plus 1. So pretty sure that's a 1 over s squared. Or squared, as I'm sure it should be known.
Yes, please, thank you.
And then I have minus 3 times, and then this should be the Laplace transform of sine of 2t, which is going to be a 2 over s squared plus 2 squared is 4. Everybody good there? All right. Hearing no objection, I'm going to put in my Laplace transform of y double prime, which is s squared, capital Y, minus y prime at 0 is minus 3, minus s times y at 0 is 1. And then the Laplace transform of y is capital Y.
Ah, shit.
You find your error?
Yep. Well, I mean, probably the first of many, but you know.
Okay. So yeah, small errors in this add up really, really well, or really, unfortunately, they compound like hella hard. So if you are finding yourself having errors, I encourage you to get in the Discord and ask someone for a double check, and do it as independently as possible. I find that I have a much harder time spotting arithmetic errors when I'm looking at someone else's work instead of just doing it myself. Once I've done it, then we can compare, and that usually gets me a better error finding result.
Mm-hmm.
So combining the left-hand side, I have s squared. Oops. I don't know why I put a parenthesis. I wasn't ready for that yet. I have s squared y plus y. And then I have plus 3 minus s. And that's going to equal 1 over s squared plus... dang it. Minus 6 over s squared plus 1, s squared plus 4. Okay, so I need to factor a y out. So I've got y times s squared plus 1. And then I need to move some stuff to the other side. So I have a 1 over s squared minus 6 over s squared plus 4. And then I have a plus s minus 3 over s squared plus 1. Wait, what the hell? Not that last part. That was just my brain being off. Okay.
Are we, because this one looks really similar to cosine omega t or sine omega t. Are we now Laplace transforming this, or did we already? I don't.
Okay, so be a little careful. When you look at this thing right now, you're looking at the right-hand side, yeah?
Yeah, so the minus 6 over s squared plus 4. That's the part that looks like cosine omega t.
But you don't have your s terms all
to one side yet.
Yeah. So right now that's
fully.
6 over s squared plus 4 looks exactly like a sine of omega t, because that's where I got it from.
Oh, you're right. You did. You cross transformed it already?
Yeah, it's identically, if you trace that term back, I'm gonna do that quick. So if you trace that term back, that term came from this term, came from this term, came from that term.
The 3 times 2 over s squared plus 4?
Uh-huh. And that was the Laplace transform of -3 sine of 2t.
Well, if we want to do the inverse, then no, that's not the same thing.
Well, so the reason I can't do the inverse yet is I have the s squared plus 1 on the left-hand side still.
You don't have all the s's together nicely.
Mm-hmm.
You have the s, okay.
So I need to get the s squared plus 1 over before I do that. So I'm going to pull all that purple train off of there. Okay, so my next step is to divide first and then inverse Laplace things. So I have y is, and then this is the part where everything gets kind of nasty.
Yeah, it really did get gross.
So one thing I might notice is I'm not going to get anything to cancel anyway, right?
Yeah.
So maybe I should be combining things now. I frankly am not totally sure what's the best call with that. So I'm going to combine it all, and this might get real messy fast. So I have a 1 over s squared plus 1. And then in these parens, I'm just combining everything. So I have an s squared times s squared plus 4 that needs to be combined, right?
Mm-hmm.
So I have the 1 times s squared plus 4 is just s squared plus 4. And then I have a, not plus 6, but minus 6s squared. And then I have plus s minus 3 times s squared plus 4. Which is hella gross. Okay, so capital Y is...
Can you pause for just 1 second?
Absolutely.
Yeah, cool. I'm trying to do this problem and take screen grabs, so...
Oh, you mean I should stop writing too?
Maybe, yeah.
Okay, let me finish writing this bottom of this fraction and then I'll stop.
Thank you for doing this, Glenn. Very helpful.
Yeah, for sure.
Thank you, Glenn.
You're welcome.
Thank you, Glenn.
Glenn's our hero. Glenn can...
Okay, so all told on the top here, I have an s squared plus 4 minus 6s squared, and then I need to multiply that friggin' thing out. So over here in the margin, I've got s cubed minus 3s squared times s squared plus 4. So foilsies gets me to, let's see, I have a plus s to the 5th plus 4s cubed minus 3s to the 4th minus 12s squared. Oops.
That's pretty gross.
Yeah, so things are gross, but the good news is all you have to do is just keep your wits about you just a tiny bit and not panic. So I'm just going to collect terms and I'll mark them off as I do. So I got an s to the 5th for sure, right? That's that one. Oh, f. Okay. So I got my s to the 5th, check. And then s to the fourths, I only have 1. So I have minus 3 s to the fourth, which is that one. And then I have s cubed. Oh, wow, these are even easier than I thought. So I only have 1s cubed. So I have 4s cubed. That's this one. And then s squareds, I have s squared minus 6s squared minus 12s squared, I think makes a total of minus 17s squared. And then I have plus 4. And then this is all over s squared plus 1 times s squared times s squared plus 4.
Did we already incorporate the s squared plus 1 into all of that, or?
It was divided, right? I was multiplying everything by 1 over s squared. So every term was going to have that in the bottom anyway.
Oh, right. Okay, yeah. We're good.
Okay. So I have this kind of nasty thing, but really all I need to do is run PFD on it anyway.
Yeah.
So I'm kind of ready to try doing that at least. So I have as plus b over s squared plus 1 plus c over s plus d over s squared plus es plus f. Come on. I don't know why the screen won't. Over s squared plus 4. It's really weird. This screen on my computer won't write on this one spot. I mean, must need to clean it or something. Okay, so I got all this stuff. Yes?
Mm-hmm.
And basically this is just like, it's tedious, but it's not very hard. So you just have to not screw it up. And Heaviside's method does help here. So I have the top is equal to as plus b times s squared times s squared plus 4. And then I have plus c times s squared plus 1 times s squared plus 4 plus d times s squared plus 1 times s squared plus 4 plus bugger. Plus es plus f times s squared times s squared plus 1. Okay, good with that?
Shouldn't c be multiplied by s squared?
C had an... Yeah, C had an
S in there, I see.
Yep.
Oh, yeah.
Shit. Okay, never mind.
Wait, what?
Okay.
Because it has an s in the bottom already, so you have to multiply just by s over s to get it to an s squared.
Cool. Thank you. Okay. So, now then, you get to pick some values, right? The one that I would wholeheartedly recommend is s is 0.
Wait, can we pause for just a second?
Yeah.
Okay.
Got the AS plus B.
The C term where we have C times S squared plus 1 times S squared plus 4.
Yep.
If we left that as S squared but kept doing the same thing for every term, would we arrive at the same answer or no?
On the bottom?
Or just like when you're finally done with everything?
So let me see if I understood your question correctly. If I put a squared here under the C?
No. On the top portion, where we have C times S squared plus 1 times S squared plus 4.
Okay.
What if we had it as C times S squared times S squared plus 1 times S squared plus 4?
Oh, it wouldn't work.
It wouldn't work. Okay.
Yeah, because you didn't need that.
Mm-hmm.
So your the top of your fraction would be off by the yeah. It would throw all the equations off too, or at least two of them. Okay, so my goal now, I have I believe 6 variables, and so I need 6 equations. And so the easiest one to obtain is the S is 0 equation, right? The top is 4, so I get 4 equals, and then there's only one term without an S in it, and that's the D term. So I get 4 equals 4 times D. Does that make sense?
Mm-hmm.
Okay, and then let's see.
Oh God, the top.
Yeah. So this is a little, like, I'm a little bit annoyed by how nasty this is, right?
I mean, we could always say we could just not do this program.
No. We can do this. It's not so bad. So the next technique would be to pick something else that's going to make the whole thing 0, right?
Yeah. Which is nothing because they're all squared.
Yeah, so you're kind of hosed on that. You can do this cheater trick where you do, like, let S be I.
Huh?
Because then I squared plus 1 is 0.
Got it.
Sure, let's get imaginary.
Yeah.
Okay, so if you let S be I, then you get S to the 5th, which is, let's see, I to the 4th is positive 1, so I to the 5th is I, minus 3, minus 4I, plus 17 plus 4. So that's the top evaluated at I. And then on the other side, I have a times I plus B.
Wouldn't the 3 be a plus 3 also? I plus 3?
You're talking about the I to the 4th is 1.
Oh, you're right, it is.
Yeah, so the powers go like this. They go I minus 1,
right.
minus I, 1.
Yeah.
Okay.
Got it.
So, and this one seems annoying, but it's the only one. So I have A times I plus B times minus 1 times minus 1 plus 4 is 3. Right. And then the one with C in it is 0, the one with D in it is 0, and the one with E and F is 0. So out of this, I have I minus 4I is minus 3I. And then numbers-wise, I have plus 18. And that's equal to minus 3AI minus 3B.
Okay, pause.
So out of this, I actually obtained two equations. I have minus 3i is minus 3ai, so that tells me that a is 1. And 18 is minus 3b, so b is minus 6. And from that other one, I had d is 1. Right?
A equals 1.
So I have to run, but your other choice is s is 2i. Which is going to zero out everything except the ES plus F term. And then if you do this same equating trick, you'll have this. Remember that when you're doing, 2i to the 5th, you have to do 2 to the 5th times I to the 5th. But otherwise, you can get this done pretty easily. And then once you've got these, so I'm just going to... I don't have this done yet, right? But I'm going to say capital Y is S over S squared plus 1 plus, negative 6 over S squared plus 1 plus, and I don't know these ones yet.
Yeah.
Right. And there's 4 more there. So you're going to need one more equation too. For the one more equation, I'd go with find the s to the 5th terms.
I see.
Because there's only one out of it.
Yeah, it should be relatively easy to find. There's one that comes with C's, and there's one with A's, and one with E's. So you'll get an equation that has A's, C's, and E's in it, but you already know what A is. And once you've done S is 2i, you'll know what E is.
So then we'll just be able to solve for C.
Yeah,
right?
Exactly.
Okay, cool.
And then each of these things are pretty chill to inverse Laplace transform.
Right.
So you'll get y as a cosine and a sine, and then some kind of exponential or something. Actually, this one will be a constant. The one with c's in it will be a constant.
Mm-hmm.
And then you'll get some other sines and cosines of 2t in this case. Does that kind of make sense, guys?
Yeah.
Okay, so I'll probably try to finish this recording later tonight here, or maybe tomorrow, and I'll drop the whole thing in when I drop it in.
Okay. Does anyone want to try to do this now?
Yeah.
I'm down.
Okay, cool.
Okay, do me a solid and pick some, like, right in green or something. Okay, have fun.